In question 3, we're going to start looking at mass and number of moles calculations. Now, we've got a definition, and that definition says there are 6.022 by 10 to the 23, or 1 mole, of carbon-12 atoms and exactly 12 grams of carbon-12. And from that definition, we're able to start relating the atomic mass, which we know is in daltons or atomic mass units, to the actual physical mass, the mass in grams of 1 mole of a substance. Let's look at how we can do that. Well, first of all, by definition, the mass of 1 mole of carbon-12 is 12 grams. So here we got, these little dots represent 1 mole of carbon-12 atoms. Obviously, there's not 1 mole there, that's just the number of dots, but let's pretend that's exactly 1 mole of carbon-12 atoms, which is 6.022 by 10 to the 23 carbon-12 atoms. And by definition, the mass of that 1 mole of carbon-12 atoms is 12 grams. But we've got on the periodic table relative atomic masses. They figure these out using Avogadro's law, measuring the different masses of different gases at the same temperature, pressure, and volume. So we know from those relative masses that the mass of hydrogen 1, which is the isotope of hydrogen with 1 proton, the mass of hydrogen 1 to the mass of carbon-12, well, obviously, is a 1 to 12 ratio. The mass of hydrogen 1 is just 1, the mass of carbon-12 is 12, so there's a 1 to 12 ratio there. And that means if we've got the same number of hydrogen 1 atoms, i.e. we've got 6.022 by 10 to the 23 hydrogen atoms, which we know is 1 mole of hydrogen atoms, if we've got exactly the same number of atoms, that should have 1/12 the mass, because each of these atoms is, relatively speaking, 1/12 the mass of a carbon-12 atom. And therefore 1 mole of hydrogen 1 atoms must weigh 1 gram, which is 1/12 of the 12 grams the carbon-12 weighs. But now we know the mass of 1 mole of hydrogen 1 atoms, that makes it very easy to look at the other relative masses on the periodic table, because compared to 1, everything's easy to figure out. So let's say we take another element. Let's say we take uranium and the isotope uranium-238. Now, if we've got this, we know that each atom of uranium-238 must be 238 times the mass of hydrogen-1. So the same number of uranium-238 atoms, i.e. 6.022 by 10 to the 23 uranium atoms, should have 238 times the mass of that 1 mole of hydrogen. So if we've got 6.022 by 10 to the 3 uranium-238 atoms, which is 1 mole of uranium-238 atoms, it should have 238 times the mass of the 1 mole of hydrogen atoms, which is obviously 238 grams. And I hope you can see the pattern here. 1 mole of carbon-12 must weigh 12 grams by definition. Therefore, because hydrogen's got 1/12 the mass, 1 mole of hydrogen 1 atoms must be 1 gram. And because uranium-238's got 238 times the mass of hydrogen, obviously 1 mole of uranium-238 must be 238 grams. And so hopefully you'll see the pattern emerging. In fact, this is where moles come very handy. The atomic mass of an element, which you see on the periodic table, which is obviously measured in daltons or atomic mass units, the atomic mass of an element is equal to the mass in grams of 1 mole of that element. And that's why the mole is so useful. It relates basically the atomic scale, the atomic mass of an element, to the everyday scale, which is the grams. If you've got 1 mole of particles, you can relate the atomic mass to the mass in grams. That's what makes moles so useful in chemistry. And now we can start seeing how that's applied. So let's go back to our 1 mole of carbon-12 atoms, which we know is 6.022 by 10 to the 23 atoms, which we know weighs 12 grams. What if we didn't have 1 mole though? Let's say we had 2 moles of carbon-12 atoms. So we've got twice as many particles now. Well, clearly, if we've got twice as many particles, we're going to have twice as much mass. So if we've got 2 moles of carbon-12 atoms, rather than weighing 12 grams, it's got to be 2 lots of 12 grams, which is 24 grams. And we can go through the whole process, but hopefully using your algebraic skills, if we had n moles of carbon-12 atoms, clearly that'll weigh n times 12 grams if we've got n moles there. And that's the basis of one of the most important moles equations we're going to use in chemistry this year, which is mathematically the mass you have of a substance is equal to the number of moles you have times by the molar mass of the substance, which is, when we say molar mass, we're going to learn what that means in a minute, it's basically the atomic mass on the periodic table. So where m is mass in grams, to find the mass of a substance in grams, you've got to know how many moles you've got, and you've got to know its molar mass. So you times the number of moles and molar mass together, and that'll give you the mass. And that should logically follow from our little example at the top here. So if you want to, you can rearrange that equation. I'm expecting you better rearrange that yourselves, but otherwise you can say that number of moles equals mass of a molar mass, or molar mass equals mass divided by number of moles. That's just the rearrangements of that particular equation there. So how can we apply this? Well, we need to know what this means by molar mass. So what's molar mass? Well, the molar mass of an element, where the isotope's not specified, if I've just said the molar mass of iron or the molar mass of carbon, or I haven't said it's carbon-12 or iron-55, when it's when the isotope's not specified, you use the average atomic mass off the periodic table. So for example, if you were asked for the molar mass of iron, so that means you've got 1 mole of iron atoms, how much do they weigh? All you can do is refer to the periodic table. So look at your periodic table now. What would the molar mass of 1 mole of iron be? Well, on the periodic table it tells us the atomic mass of iron is 55.85, so if you've got a mole of iron atoms, you can say the mass is 55.85 grams. But what about for a compound? Here I've got a mole of water. Here's my mole of water particles. How can we find the molar mass of water? Because it's not on the periodic table. Well, we can use our brains here. We can say, well, 1 mole of water molecules, well, it's got, if we look inside that, every water molecule's got 1 oxygen and 2 hydrogens. So when we think about the particles we've got basically 1 mole of oxygen particles here and 2 moles of hydrogen particles there. And if I just asked you what's the mass of 1 mole of oxygen, you tell me straight away 16 from the periodic table. And if I say what's the mass of 2 moles of hydrogen, well, you'd figure out the mass of 1 mole of hydrogen, which from the periodic table is 1.008, and you just times it by 2. So the molar mass of water is just 2 lots of 1.008 plus 16. So 2 lots of hydrogen molar masses plus 1 lot of oxygen molar masses. And that equals to 18.016 grams. That's the molar mass of water. So for elements and compounds, we can figure out the molar mass. And therefore, if you're told a certain number of moles of elements or compounds, you can figure out the mass in grams of that substance you've been given. And that leads to example 3 in your notes. You've got a lot of examples here. I'm not going to go through the worked answer for each one because once you've learned how to do it once, you should be able to apply that again and again and again. I'm just going to go through the ones that are in colour. Silver, oxygen, ammonia. This is a calculation question. There are moles of lead-2 iodide and how many moles in 150 grams of ethene. Down the list there as well, I'm just going to underline a few. I'm not going to go through these ones, but these ones you've got to think about. For this one here, please make sure you actually use your cross method to figure out the formula correctly first before you try and do the calculation. For this one here, once again, butane, that was in our first assessment task, naming these hydrocarbons. Figure out the formula, figure out how many carbons and hydrogens in that compound before you do the calculation. Down here, little trick, don't forget that fluorine gas is diatomic, so don't forget to include that in your calculation. And down here, little trick here, in our moles calculations on the previous slide, it said we had to use the mass in grams. This one's been given to you in kilograms, so make sure you convert that to grams before you start your calculation as well. So how do we do these questions? Let's look at this first one, in red, number 1. We've been asked, what's the molar mass of silver? And we've told on the previous slide, the molar mass of an element is just the average atomic weight from the periodic table. So all you've got to do is say, well, the molar mass of silver, which is that capital M there, straight from the periodic table, have a look. You should find it is 107.9 grams per mole. So the molar mass has units, it's grams per mole. How many grams are there per mole? However, for elements that exist as molecules, the molar mass of the molecule equals the sum of the atomic weights of all atoms in the molecule. So we've been asked to find the molar mass of oxygen gas. Now we know that oxygen gas exists as, drumroll everybody, hope you know this one, oxygen gas exists as O2. Thus, the molar mass of oxygen must be the mass of O2, which is 2 lots of 16. And therefore, the molar mass of oxygen gas is 32 grams per mole because it's O2. Next question, we've got a compound. Now we've been given a compound here, ammonia. Now for compounds, as we saw with water on the previous slide, the molar mass equals the sum of the atomic weights of all atoms in the formula. And what does that mean by formula? Well, for covalent molecular substances, it's the molecular formula. For metallic ionic covalent network substances, it's the empirical formula. So when we say formula, it's just the formula we normally write down. So the molar mass of sodium chloride will be adding sodium and chlorine together because the formula is NaCl. So it's empirical formula for metallic ionic and covalent network, but molecular formula for covalent molecular. So ammonia, you should know what ammonia is. If you don't know what it is, this is your chance to learn this because you expect you know this from now on. Ammonia is NH3. Thus, the molar mass of ammonia, which is the molar mass of NH3, is just 1 lot of nitrogen plus 3 lots of hydrogen. So the molar mass of ammonia is just 17.034 grams per mole. Down to this question here. This time we've got to do a calculation. It's not asking us for the molar mass. It says what is the mass of. We've got to use that number of moles equals mass of a molar mass, or mass equals number of moles times molar mass formula. So we're going to start getting into calculation chemistry here. And whenever you do calculations in chemistry, there's a few simple rules to follow. I always write down my equation. I write down my data from the question and make sure I've converted it to correct units. I calculate the formula of my compound. So this is a situation we've got a compound. Get your formula of a compound right using cross method first before you do the calculation. And we're going to look at some more complex examples, but there's a simple little rule I follow when I'm trying to solve chemistry questions. It's the sword of chemistry, or the sword of chemistry, to slay my chemical question opponents. And if you follow this technique, you will always, or should always, get your answers right. Data, equations, substitute answer units, double check significant figures. Okay, data, write down the data from the question with the proper units. Equation and formula, write down the equation you're going to use to solve the question and make sure you get your formula right using the cross method. Substitute. Show your substitution of your data into your equations. Okay, that helps you get marks. Write your answer down. Make sure you include units at the end of your answer, and go back and double check your working and double check the significant figures before you submit your answer. For physics, that D can also stand for direction. Make sure you get your directions of your vectors right. So using DSORD, let's solve this problem. First of all, here's my equation. I'm trying to figure out what is the mass. So I've written down my equation for mass. Mass equals number of moles times molar mass. Next, I write down my data. So I don't know the mass, I'm trying to find it out. But I've been told the number of moles is 2. And I've got to figure out the molar mass. But I've been asked to figure out the molar mass of a compound, so I better get that compound formula right. So please use your cross method now. Can you get the formula for lead-2 iodide right? Pause it and have a check in a second when you've had a go. Okay, so hopefully you got PbI2. How are we going to figure out the molar mass of lead-2 iodide? Well, once again, I'll have a little pause here. You can have a go at figuring out the molar mass yourself, and then you can check your answers. Okay, so you should have realized it's 1 lot of lead's molar mass plus 2 lots of iodine's molar mass from the periodic table will give us 461 grams per mole. Next thing is we've got to substitute. So I've got my equation here. I'm going to substitute my numbers in. Number of moles equals 2. The molar mass is 461. So the mass of 2 moles of lead-2 iodide is 2 lots of 461, which in my calculator tells me 922 grams. Now, whether that means exactly 2 moles or whether it's supposed to be one significant figure, it's unclear. So in these sort of situations, I'd write down the full answer, and then as a next step, I'd write it to one significant figure, which is sort of what this one looks like. And so once again, next question, we got this one here. How many moles of the following chemicals in 150 grams of ethene? So once again, I'm going to use DSORD. So this time I'm asked how many moles. So the equation I'm going to write down, well, the equation we've got is mass equals number of moles times molar mass, but we can rearrange that to number of moles equals mass of a molar mass. The next thing, I write down my data. I've been told I've got 150 grams. I'm trying to find the number of moles. I've got to figure out the molar mass. To find the molar mass, being a compound, I've got to get the formula right. So take a little pause the video, see if you get the formula of ethene right, thinking back to your first assessment task. Okay, hopefully you've remembered that ethene is C2H4. Now to calculate the molar mass, once again, have a little pause, do the calculations, see if you get it right. So the molar mass should be 2 lots of carbon plus 4 lots of hydrogen, which is 28.052 grams per mole. My next step in my DSORD is to substitute. So I'm going to put number of moles equals mass of a molar mass, which is 150, divided by 28.052. Then I do my answer, which is 5.347, because the atomic mass on the periodic table are 4 significant figures, but this question had 2 significant figures, so I'm going to round my answer off to 2 significant figures, which is 5.3 moles. So you've got 5.3 moles if you have 150 grams of ethene. Now, for the rest of these questions, I'm not going to go through the working, but I'm going to give you the answers here. Feel free to pause this and have check your answers as you go, or print this out. But here are the answers to those questions. Make sure you do them and check them all, because you need to be able to do these to answer some questions from your assessment task. And from now on, finding molar masses is the foundation to solving all problems from now on, because we need the molar masses to do moles calculations.